Say?
Secant squared of x.
Secant squared of x, and if I said find the derivative of the square root of x,
1 over 2
square roots of x, good. And if I said find the derivative of e to the pi power,
e to the pi power
Constant.
0.
so your derivative would be, well done. Sure, take one of his. He's got lots. All right. And, quotient rule.
Low-D high minus high-D
minus
high-D
low
over low.
Good. All right, so let's shake things up a little bit. Specifically, I want to talk about implicit differentiation. Implicit differentiation. Here's the thing. It's been a while since we've played this game. Implicit differentiation is what you do when you have your x's and your y's mixed in together on the same side of the equation. We spent a couple of days on this back in October, November. This was right after the pit of despair, those optimization problems. So you might still be in trauma mode, but implicit differentiation was really easy as long as you remembered one thing. Derivative of 3y cubed?
9y squared.
That junk out of here. Derivative of 3y cubed is 9y squared, close but wrong. Times dy dx. Jose, why times dy dx? Because we're taking the derivative with respect to x, right? The instructions at the top said find dy dx. We're finding the derivative with respect to x. So the derivative of 3y cubed is 9y squared times dy dx because of your chain rule. Plus derivative of x squared? 2x equals derivative of 5? 0. Good. Not the final answer though. Daisy, why is that not the final answer?
Don't you have to find dy dx?
Right, you want to find dy dx, and we're going to resist the temptation to say, oh, there it is, found it. Right, you want to solve for dy dx. So what are you going to do to finish it off, Daisy?
Move the, subtract negative, plus 2x,
Okay, we're going to subtract 2x to the other side, and then?
and then do the same for dy squared.
Okay, hold on. We've got 9y squared times dy dx plus 2x. I agree, you're going to subtract the 2x, but then we need to divide. Everybody okay? So dy dx equals negative 2x over 9y squared. And this problem, that's all that they wanted. Find dy dx. Got it? Good. Rombier, dy dx, what is that really?
The derivative.
That's the derivative, right? When I think about that word derivative, I hear some other words in my head.
Slope.
I hear not just slope, slope of tangent line. And so one of the things that we used to do all the time back in the day is I might say, hey, there's the derivative, right? You found the slope. I might say, hey, where is the tangent line horizontal? So if I wanted to know about a horizontal tangent line, tell somebody near you, what's your plan? Horizontal tangent line, how are you going to find it? Horizontal tangent line. Careful. Can you guys all show me a horizontal tangent line? Oh, so sorry. Horizontal tangent line, what do we know? What do we know about the slope? 0. Slope is 0. So if the slope is equal to 0 and this is my slope, right, my slope is a fraction, where's that going to be equal to 0?
The top.
It's the top. I need the top to be equal to 0, so that means that x is going to have to be equal to 0. It's just the top that I need to be equal to 0. Juan and friends, we're okay? Now, sometimes in a problem like this, they don't just want the x value, but they also want the y value. Christian, do you remember what you would do if they said, like, the point?
You would plug in.
Plug 0 in where? Back to the derivative?
No, to the.
Right, you want to go back to the original. So if you ever have one of the values but not the other, you need to go back to the original. All right, have a quick conversation with somebody near you. The new question is vertical tangent line. Jennifer, I'm coming over. How would you get a vertical tangent line? What do you know?
Find the vertical tangent line.
Wait, no, you plug it into infinity once you find the limit to infinity once you find the candidate.
All right, you guys show me vertical tangent line. Vertical tangent line. Vertical tangent line. Martyr, what do you know about a vertical tangent line? What do you know about the derivative at a vertical tangent line? It's undefined. I'll definitely be listening closely tomorrow. All right, so the derivative is undefined. If the derivative is undefined and my derivative is a fraction, there's only one reason my fraction will be undefined, Edgar. Why would my fraction be undefined? Oh, sorry.
Oh, because the bottom equals 0.
Because the bottom is equal to 0. So I'd say, oh, that means that 9y squared is equal to 0. So y is equal to 0. If I needed the point, I let y equal 0, go find the x value. Is this comfortable?
Yeah.
Familiar? We've been here. It's just been a while.
For a while back.
Okay, now here's where things get a little bit uglier. And I want to do this one for those of you that are like, no, my smarticle particles are good. I've got this under control. Go for it. You don't need it. Problem number 2, x squared y minus 2x cubed y equals x plus y. The instructions still are find dy dx. So I'm going to go find a derivative. And already this first one, we're going to have a little bit of a problem. Okay. The key here, if I'm going to find the derivative of x squared y, maybe you want to think of it another way. I'd look at this as x squared times y. If I'm going to take the derivative, Edgar, Abraham, how are you going to find the derivative?
How put separately?
Okay, so product rule says derivative of the first, so 2x, but leave that second one alone, right? Derivative of the first, leave the second one alone, and then what?
You add.
And then I'm going to add
Plus the
first,
times the root.
and what's the derivative of y?
dy.
dy dx, good. All right. Everybody okay with the derivative for the first term? Okay, next one, a little ugly. A little ugly. That negative sign used to wreak havoc in here. Because that's really -2 times all the stuff that comes after it. One of the things that we used to do to kind of keep track of things, we'd say, all right, so this is -2 times the derivative of x cubed y. And just writing that little d dx in front says, I know I have to take the derivative. I haven't done it yet, but once I find that derivative, I'm going to multiply by -2. So I'm just like putting a pin in this and saying, let me come back. Now I'm on the right-hand side. I need the derivative of x, and everyone's going to tell me? Oh, derivative of x. X is not a constant. 1 plus derivative of y. dy dx. Great. We're done with all the calculus, except one little part. Right, we still got to go back over here. Okay, so find the derivative of x cubed y. Derivative of x cubed y, I see 3x squared times y plus x cubed times dy dx. I still have to multiply everything by that -2. It's got to get distributed. And then I've got 2xy plus x squared dy dx. Over here, this is equal to 1 plus dy dx. For those of you that just went solo, how do we do on the derivative? Nobody went solo. Okay. Okay. Good news. Calculus, the calculus part of this problem, done. I need to get dy dx by itself. The only thing left is algebra. Yes. Have a quick strategy conversation with somebody near you. What are you going to do? Right, the key here is to solve for dy dx. The problem is dy dx is showing up 3 different times. What was the key? What was the key? So I'm hearing some folks saying factor it out. I don't know that factoring out is really what we're ready for yet. If I've got a dy dx over here, I've got a dy dx over here, and I've got a dy dx over here, the first thing that you have to do is rewrite this so all the dy dx terms are on one side so that you can then get to the factoring. Anything that doesn't have a dy dx, you normally put on the other side. So let's do some quick algebra here. We've got 2xy plus x squared times dy dx. Distribute the negative 2 through, negative 6x squared y. Negative 2x cubed dy dx equals 1 plus dy dx. And this is where I lost the last class and I did not mean to. Here's a dy dx. Here's a dy dx. Here's a dy dx. If I'm going to solve for dy dx, get dy dx by itself, all 3 terms that have dy dx have to show up on one side. All of the 1, 2, 3 terms that don't have dy dx got to be on the other. So it's just going to be a little bit of algebra. Okay, x squared dy dx, check. Negative 2x cubed dy dx, got it. Dy dx over on the right, I need it over here. I'm going to subtract it. Check. 2xy, I don't want it on the left, move it over to the right, so that's a negative 2xy. Check. Negative 6x squared y, I'm going to move that guy over. Check. Plus 1. We're almost there. Right, now dy dx, dy dx, dy dx, you did all that work to get the dy dx's on one side. Now you factor it out. And then you divide both sides by all the stuff. And I know back in the day, most of you guys were really comfortable with just jumping straight to negative 2xy plus 6x squared y plus 1. And what am I dividing by? All the stuff that you get after you factor out the dy dx. So you're going to divide by x squared. You're going to divide by negative 2x cubed. You're going to divide by negative 1. There's dy dx. Okay. So let's do this. I'm going to give you guys a couple minutes to practice here. Let's do this one. Let's do this. There are on page 3, I think question number 3 and question number 4 would be really good ones for you guys to try. So I'm going to put about 3 minutes on the clock, focusing on, what did I say, 3 and 4? 3 and 4. If you've got any questions at all about what happened on these 2, now would be the time to ask those questions. Jonathan, you have question face. What's up? No. Over here on page 3. It's 3 and 4. Tomorrow during the test? Yeah. You space out work. You'll have questions.
know there's like school, but there's like no
Edgar, give me some paper.
Just give that to me so it's.
Okay. I'm going. I'm going.
Just even zero. So when we got zero, we got zero. Oh, thanks, man.
Friends over here, anybody do the
No, I
apple
didn't
pie?
already.
Good choice. And
I didn't get that.
thank you.
So,
All right. Friends over here, anybody do the optional sign? Okay, not judging. Not a good choice. Okay. friends over here. Okay.
Edgar, don't pass up
The next step is turning the just put all the UI over the side.
One over square, all of it over 6x squared. Oh, hold on. Why did I do no? Because I subtracted my dydx over here, so I did negative dydx. And then I divided by 2x to get 2x on the other side. And then since it was just 6x squared, I don't know what I did.
Yours have some.
All right.
D, you said for like number 3, it's 2x cubed times y. You said to separate the 2, right?
Right, normally like I pull the 2 out. Some people don't. They just keep the 2 and use it in the product rule.
Oh, okay.
That works as well.
That's what I did.
All right. All right, so number 3, if all goes well, your derivative is 2xy plus x squared dy dx plus 6x squared y plus 2x cubed dy dx equals 1 plus dy dx. How many of you guys had that first derivative part? And dy dx is in the right place. After that, it's just algebra. Like this guy has a dy dx, keep it on the left. This guy has a dy dx, keep it on the left. That guy has dy dx, it's on the wrong side. Move it on over. Do a little factoring. Divide, bada bing, bada boom. Number 4 gets a little bit uglier, not horribly so. I'm not sure how many of you guys made it here. But if it's x squared e to the y, just take a derivative. Derivative of x squared, 2x. Leave e to the y alone. Plus x squared times the derivative of e to the y is e to the y times dy dx. Chain rule. Whenever you take the derivative of something with a y, you have to have the dy dx. Hold on just a second. Plus over here, derivative of y is dy dx. Leave e to the x alone. Plus y times e to the x equals 0. Yes, ma'am.
I thought for the last one, when you found the derivative, I thought since we're doing like the second one times the derivative of the second one, like on the last one, I thought you would have to multiply that by dy dx.
You're saying over here, when you find the derivative.
For the last one,
Yep.
like,
So that connects with these two over here. The derivative of the first is dy dx times leave e to the x
second.
alone. Plus, you're leaving the y alone. And what you're taking the derivative of is e to the
oh, it's
x.
e to the x. That's why I got confused with the variable.
Okay. All right, so now it's time to put your money where your mouth is. Okay. All right, so I want you guys to look at the free response question. We're going to spend the next 15 minutes on this, and we are going to stop at 4 o'clock, even if we are in the midst of greatness. We have done this one before. This is not a new problem. Hi. Not sure what that is, but I'll put it right over there. Thank you. Somebody remind me later on, I just took a piece of paper from her. Okay, one of the things that they like to do on the college board is they're going to give you a curve. Not a function, but a curve. And they're going to say, show that the derivative is this guy over here. Show that dy dx equals 3x squared minus y minus 1 over 4y cubed plus x. That's already the derivative. You just have to show that that actually is the derivative. This is a 2-point question. I want you to take 2 minutes, completely on your own, no help from anybody. Show me what you can do. And let me figure out what this paper is that I just turned. That's gonna be. Up yet. Somebody just stopped by and dropped off the pre-calculus unity tests. The test on vectors. Oh. I cannot emphasize enough, especially when it comes to like where you've got multiplication happening, using that ddx notation is going to be really helpful to just say, this is my derivative over here, but I've got to distribute that negative sign through. After that, it's just distributing, collecting the terms that have a dy dx on one side, ones that don't have a dy dx onto the other, factor at the end, divide, done. Now, with 11 minutes left, even if you didn't get 100% of the way through part A, I want to move on. Because one of the things they like to do on the AP exam, and this is a gift to all the calculus teenagers on the planet, they've given you the derivative. You get to use this moving forward. Part B is worth 2 points. Determine the equation of the line at 1, 1. Have a quick strategy conversation with somebody near you, and then put that strategy into practice. This is worth 2 points. Do not overthink it.
I don't know if you got into the
Doesn't it give you the slope? Okay, yeah. Don't you have to do like the whole thing?
All right. First thing we're going to do is plug in the 1 and the 1. So what do we have? 3 times 1 squared minus 1 minus 1. 4 times 1 cubed plus 1. 1/5 is going to be the slope. Knowing to use the derivative and getting the 1/5 is probably worth a point. Then you're going to write the equation of the tangent line, 1/5 x minus 1 plus 1. I'd say probably 1 point for coming up with the slope, 1 point for the equation of the tangent line. How many guys would have just earned both points? Okay, good. Now let's go for a 4-pointer. Part C, determine the concavity of the curve at 1, 1. Be sure to justify your answer. Concavity, talk to somebody near you. What's the plan here? There's only one curve we're talking about. It all goes back to this curve. Remember, you're not going to get the graph. The graph is just there to help you visualize what's going on.
Oh, well, yeah, you know, this.
The concavity one is the end of the sheet is there.
From decreasing.
The packet. No, the yellow one. The yellow one. I don't like it. I don't like the derivative.
Okay, just a friendly reminder, don't look at the graph. They would never give you the graph because that's just there to help you like understand what's going on. It's a 4-point question. So, get a quick review here. Can you guys all show me concave up? Concave up looks like this, right? That's one way to think about concavity. The function, the original curve looks like this. How about the derivative? Oh my gosh. If the graph looks like this, the derivative? Increases. And the second derivative? Positive. Way back in the day when we were babes in the woods, we used to draw that guy all the time.
Hey.
Smiley face, because you're concave up. The 2 positives, because?
They're derivatives. Tangent lines.
The tangent lines, first of all, they're not overestimates. The reason for the two plus signs there, the second derivative is positive. When it comes to concave down, That's what you're gonna look like tomorrow if you haven't studied tonight. Yes, that guy. Now, the whole like concave up, concave down, tangent line overestimate, tangent line underestimate. If my graph is concave up, where are the tangent lines?
Under. Over.
Where are the tangent lines?
Under.
Imagine drawing a tangent line.
Under.
They have to be
Under.
under.
Where?
So, underestimate, overestimate?
Underestimate.
Has to be an underestimate. All right, so the key here is to look at d squared y dx squared. I have to look at the sign of the second derivative. The reason why this is a 4-point question, finding the second derivative is not going to be easy. Okay, if I'm going to find the second derivative, that means find the derivative of the derivative. Coming up with the derivative of the derivative is worth 2 points. Take a minute, get this done. Don't talk to anybody around you, show me what you can do. Jose, pick up the pencil.
The derivative of that?
The derivative of that.
No.
The derivative of that fraction, otherwise known as a quotient.
I'm gonna keep my hand. That sounds weird.
Oh my god.
Be careful. Okay.
Not that far.
4y cubed plus x. So low, d high is going to be 6x minus 1 dy dx. Minus.
Wait, doesn't the 4y cube have to, and plus x have to be put to the negative one column?
Not really. If you're going to do a quotient rule, you leave that in the denominator. I think, Rumbier, what you're trying to do is rewrite this as a chain rule.
Yeah, never mind. Okay, so I was doing it wrong.
Okay. Low d high minus high d low, low, low. Okay, you did the derivative correctly. The 4y cubed plus x stays exactly the way it is. But the derivative of the numerator is 6x minus 1 dy dx. If you don't have the dy dx there, it's wrong. Minus, and I cannot encourage enough, big parentheses here. Now it's leave the numerator alone, derivative of the denominator. 12y squared dy dx plus 1 over low, low. How many of you guys would have gotten this as your derivative? Okay, 2 points. Not done. Where do the other ones come from?
The chapter.
Right, they want concavity at 1, 1. So what do you have to do?
Evaluate.
You're going to have to figure out positive or negative. Or as Edgar just said, we're going to evaluate. So I need to find that second derivative at 1, 1. Just got to plug it in. Everywhere there's an x, put in 1. Everywhere there's a y, put in 1. All right. 4 times 1 cubed plus 1. How about 5? 6 times x, 6, minus 1 times dy dx.
Already know.
You already know what dy dx is.
105.
Right, Noemi, what's dy dx?
Oh my god.
Careful, dy dx at 1, 1. We already figured out it's 1/5, so that's a place where you get to use that. Minus 3 times 1 squared, 3 minus 1 minus 1. 12 times 1 squared is 12, times 1/5 plus 1 over 4 plus 1, the whole thing squared. And for all my friends who are being well raised, you know not to simplify. However, there's a problem. We have to figure out if this thing is positive or negative. Okay? So like, you know, I'd say this is probably worth like 1 point. You effectively plugged everything in, but you're gonna have to make some decisions. You're gonna have to do whatever level of computation you need to figure out positive or negative. So 6 minus 1/5
Positive.
is positive, okay. And 5 times positive? Positive. 3 minus 1 minus 1?
Positive.
Positive. 12 times a fifth?
Positive.
Plus 1.
Positive.
Now here's going to be the problem.
You know what you're
Positive minus positive.
Positive.
No, you don't know. Yeah.
But it's not.
Positive minus positive could be positive, could be negative, could it be 0?
Yeah.
You can't just say, oh, I know this guy's positive. You're going to have to go a little bit further. So maybe you want to do a little bit of mental math here and say like 6 minus 1/5, get a common denominator. 30 over 5 minus 1 over 5, 29 over 5. 5 times 29 over 5. Minus 3 minus 1 minus 1, 1. 12 times 1/5 plus 1 is 12 over 5 plus 1. It's not pretty, I know. 5 times 29 over 5, 29. Minus 12 over 5 plus 1.
That's a small positive.
I swear, these are things that we can all do.
17 over 5.
Is 17 over 5. Okay, what I heard Ron Beer just say is that's a small positive number. Compared to 29, like 17 over 5 is, what, 3 and a little bit? 29 minus 3 and a little bit?
20 something.
All I really care about? 25. Positive over 25?
Positive.
The conclusion? The
Concave.
only conclusion? The only conclusion is the graph is concave up. And if that's all you write, you won't get the point. Jonathan, why not?
Got it.
The graph is concave up will not get you the point. Jonathan, why not? Because that's the second derivative, and we figured out the second derivative is positive. That is a good thing. Jennifer, why not?
You have to say x equals 1.
Not at x equals 1. At the point. The point is x equals 1 and y equals 1 at the same time. Otherwise, if you say concave up, you're saying concave up in all the places, and that's the problem. Okay. That was about what I wanted to accomplish with implicit differentiation. Yes, we've only got about 8 minutes left, and one more topic that we're going to talk about. Nora, it's going to be okay. I'm well trained in these Jedi arts. One of the other things that we used to play around with back in the day, I just want to get a good running start at this.
What did I give you to?
It's this cone problem down at the bottom.
Did you take it? Yeah, I think I took it.
It's been a while since we've played around with these things, but take a minute, read through this, mark it up, let's be ready to talk in a minute.
Did you put it this way? Did you put it this way?
Okay, let me say that one more time. Not time for side conversations. Wait it. Read it, mark it up. Related rates. Jose, this one.
He's tried all the way.
At around the same time that we talked about implicit differentiation, we talked about something called related rates. This is when we were looking at how things change over time. We had snowballs melting and fish tanks were losing water and ladders sliding down walls, all the things. All the things were happening. The most important thing though is that we were looking at how things changed over time. All the derivatives were with respect to time. So in this problem, we've got a conical water tower that has a height of 12 feet and a radius of 3 feet. Water is pumped into the tank at a rate of 4 cubic feet per minute. That rate of 4 cubic feet per minute is telling you something important. What's it telling you? Let's get some hands on this. What's it telling you? I see 4 people. Water is pumped into the tank at a rate of 4 cubic feet per second. Noemi, what's it telling you?
The rate of change,
The rate of change of what?
the water leaving the tank.
Okay.
Oh,
Water is being pumped into the tank at a rate of 4 cubic feet per minute. It is a rate of change. David, what's it the rate of change of? Is it dr over dt? Look at the units. Read this problem one more time. This is dv dt. Right? This is 4 cubic feet per minute. That has to be dv dt. Noemi, positive or negative 4 cubic feet per minute?
positive.
Why?
It's pumping into.
You are pumping water into the tank, so dv dt. How fast is the water level rising? How fast is the water level rising when the water level is 6 feet? So I want to know, hold on, more variables coming. What's dh dt when the height is 6 feet?
Oh, that big equation.
Right. Now, way back in the day, and we've only got about 5 minutes, so I'm going to have to go faster than I'm comfortable with. I'd ask lots of questions about, are these things always true or are they sometimes true? So for example, dv dt equals 4 cubic feet per minute. Always true?
Yes.
Sometimes true?
Always.
If you read the question, this is always true. This is not going to change. The height being 6 feet.
That changes.
I mean, it starts off over here.
When, it's just when the water is 6 feet.
When the water is 6 feet. Well, what's happening, right? Noemi told us we're pumping water into the tank. And as I'm pumping water into the tank, that's what these little circles are there for, that water level's rising. Right? So I'm going to use H to indicate the height of the little water level, and R to represent the radius of that little slice, like the orange is for the water. They also told you that the conical water tower has a height of 12 feet and a radius of 3 feet. Always?
Always.
Sometimes?
Always.
Radius.
Grombeer, why always?
Because it's not going to change.
What is that 12 feet and the 3 feet? They're talking about the cone, right? Not the water in the cone. They're talking about the cone. So I've got this other height of 12 feet and this other radius of 3 feet. And I'm drawing them this way for a reason, because I'm trying to get you guys to remember there was this important relationship that happened with the cones. And it had to do with when the water is going up, you're getting like these little triangular regions. And if you compare it to the black, you've got similar figures, right? You've got this black triangle, and then you've got this orange triangle. The big black triangle looks like this. You've got a height of 12 and a radius of 3. The little orange triangle, the height keeps changing and the radius keeps changing. Adriana, you okay there? All right. See, like trying to hide under your sweatshirt. So the key here is you've got similar figures. Because they're similar figures, your life gets really good really, really fast. Right, what I can do is I can set up a proportion that says the ratio of 12 to 3 is equal to the ratio of the height to the radius. You can do a little cross multiplying to say that 12r is equal to 3h. If you want, divide by 3 to get 4r is equal to h. Always true or sometimes true?
Always.
This is always true. Because this is always true, your life just got remarkably better. Why? Why did your life just get better? Edgar sees it. Marvin thinks he sees it. Noemi thinks she sees it. Edgar, why did your life just get better?
Because you know what the radius is. So you can just plug in.
Okay, you know what the radius is. There's another really good reason why this just made your life really, really good.
Because
If the height's always equal to 4 times the radius, Martyr, what's the thing?
You can find the radius at
Any height.
Right, I mean, they're asking you when the height's equal to 6 feet. I think we can figure out the radius pretty quickly there. Right, this says that 4r is equal to 6, so what is that? Like 1.5
Yeah.
feet or 3/2? But the real reason why your life just got good, we just need 1 more minute. rather than working with this volume expression that says 1/3 pi r squared times h, where you've got a radius and a height and you're having to work with both at the same time,
One variable.
right? You know that the height's always equal to 4 times the radius. Plug it in. Okay, so now you've got volume equals 1/3 pi r squared times 4r. That looks good. I can do better. You guys can do better. 1/3 times pi times r squared times 4r is the same thing as 4/3 pi r squared times r. Is going to be r cubed.
Oh,
It's just some algebra stuff. 1/3 times pi times 4, those are all constants. R squared times r, multiply them together. What you want is dh dt. They gave you some dv dt. Real quick, just get me the derivative. We're not going to finish it off. We'll stop there. Just get me the derivative. Be careful. If all goes well, dv dt equals 4/3 times pi times 3r squared and the dr dt. How many of you guys had the dr dt? Right, related rates. We're measuring how things change over time. Hold on, Nora. Okay, dv dt we know is going to be 4. You've got the 4/3 times pi times 3. Do we know the r? I think we figured out the r. 1.5 squared dr dt. If what I want is dr dt, I'm just going to divide. I'm not going to bother with simplifying. We're out of time here. 4/3 times pi times 3 times 1.5 squared. And sadly, come on in. Sadly, I ended class last period and I left that on the board. And it wasn't until Jasmine came up and said in her special Jasmine way, I think you made a mistake. And I did. Come on in. Where's the mistake? Where's the mistake? Where's the mistake? Knowing me, where's the mistake?
There's no units.
Okay, there's no units. What would the units be for dr? How are we measuring radius? Feet. How are we measuring time?
Minutes.
Minutes. That's not the mistake. Only Jasmine caught it. Mariah, do you see it? David, do you see it? Leaving the 1.5 without squaring is not the problem. What are we looking for?
DH.
DHDT.
oh, Dan, we have to flag that.
Yeah. If I wasn't being filmed, I'd be like, crap. But you know, I'm not being filmed, so I can't say that. I have to edit that part out. Okay. DRDT. We want a DHDT. 99% of the work is beautiful. Blew it a little bit there at the end. All is well. We're gonna start in Miss Meyer's room in about 8 minutes.
That's the answer, just change
That's the answer for DRDT. You could go back over here, Ramir, and say if I take a derivative.
Yeah, it's okay.
Hey, you asked a question. You could just go back over here and say to get DHDT, it's just gonna be 4 times what you get over here.
Borrow somebody's
Yes, ma'am.
Bum, ba-dum, ba-dum, ba-dum.
So here's a